Hello, this is Mike at Gamefromscratch, and welcome to our ongoing LibGDX tutorial series. Today we're going to be continuing on covering Scene2D, the scene graph that's built on top of LibGDX. In the previous part, we looked at an introduction, and we discussed that Scene2D is mostly composed of three things: the stage, where everything happens; actors, which are the things that comprise your game world; and actions, the things that make actors do stuff. Today we are going to be looking specifically at actors and actions. We'll start it off with actors. An actor, as I said earlier, is basically a node in your game. It's an entity with a shape and a position, but not necessarily a graphic. We'll see that shortly. Your game world would essentially be comprised of actors. So if you were creating, say, Pong once again, or so we'll use Pac-Man to use a different example. Pac-Man, the ghost, the pellets, those would all be actors within your world. Let's go ahead and see how this works now. I'll just load up my project. Alright. It's already been pre-configured, so I just need to go in. What we're going to do first off is we're going to inherit a new class. Actor is more or less the base class of the scene graph. There are a number of things that derive from actor, mostly UI and widget controls. However, when you're making your own game, normally what you will do is inherit your different game objects from actor itself. So that's exactly what we're going to do today. In order to do so, we just come on in here, and we'll add a new class. Obviously, the process is going to be slightly different if you're using Eclipse, but it should be fairly straightforward, and it probably works out almost the exact same way. But let's add a class called myActor, and myActor is going to extend actor, like so. That brings the import in. All right. So there's our actor class. Now let's go back to our demo. Switch over to presentation mode so you can see what I'm doing. Okay, so now what we're going to do is just create our stage and create an instance of our actor. We're not going to do a whole lot in this example. I just want to show you how you create an actor and a few important parts about it. Most of what we're going to do in this particular portion we actually already did in the introduction. So let's get rid of all the stuff we don't need. Add the things that we do, such as a stage. I'll enter to select which one. So we will use that guy as our stage. And since we aren't using any of these, we will get rid of them. And all we are going to use down here is clear, because if you remember, the stage is responsible for its own rendering. So we just come on in here and we will create a viewport. Like so. And then we will create our stage using our newly created viewport. Like so. Wire the input handling so that it is being passed to our stage, which once again is an input processor. Like so. Instantiate our actor. So, and finally down here in our render, we are going to add stage.draw, which will cause the stage to be drawn. This we all saw in the introduction. This is how you do a basic stage, add an actor to it, and all of this is very familiar. Now we're going to introduce, I believe, two new concepts. We might have already covered act in the first part, I'm not sure or not, but what you're going to do before you do an update is let's go in here and go stage.act. And what act is like update. So if you have a bunch of things in your world that are moving, need calculations on a per frame basis, etc., you would put it in the act function. Ditto when we deal with actions. Actions are updated when act is called. So when we get onto actions, calling act right here is very important. And all you do is you pass in the amount of time that's happened since the last frame. And that's done by calling get delta time. Okay, so that's the only change we're going to make there. So each frame before we draw, we are going to update act. So what this essentially does is stage then calls act on every actor in its scene, and then stage calls draw on every actor in the screen. One final thing we're going to do is back over here you need to set, we're going to be doing some keyboard input onto our actor. In order to pass keyboard events into an actor, you have to set focus to it. That's just a matter of calling set focus. Now, that's it. So now keyboard events will be handled, will at least be passed to our actor. Our actors are still going to be responsible for dealing with them, but this wires it up so that it receives keyboard events. It's very important that you do this if you need keyboard handling in your actor. Now let's switch back to our My Actor class. Let's see if I can, no I can't. I'm not sure how to do this in presentation mode, so 1 second. Alright, now we're back to our actor class. This is My Actor. Obviously we've done nothing with it yet. Let me just get rid of this garbage content here. And all we are going to do in our actor is listen for import or touch events and then move accordingly. First thing we're going to do is our actor here, our actor has position, but it has no substance. An actor is just a thing in our scene. There's no graphic attached to it, or there's no texture attached to it, nothing like that. So we need to actually have some visible representation for an actor, or you have to use a derived class from actor, which we'll touch on a little bit later. But what I'm going to do right now is create a sprite. It's actually sort of overkill because sprite has positional information and actor has positional information, but that's what I'm going to do anyways. So, create a new sprite from the default texture that is in the default project. So obviously you can use whichever file you'd like. Alright, so our actor is going to have this sprite graphic. And now let's go ahead and in our constructor, we're going to set up our actor. Now there's a very important call you have to make when dealing with actors. And as I said earlier, an actor doesn't have a visual representation initially. So now that we've loaded a sprite in to deal with it, we also have to set the bounds of the sprite, or set the bounds of our actor, so our actor knows how big it is. If you do not set the bounds on your actor, all kinds of things won't work. Touches won't work, a lot of your movement or rotation code won't work, etc. So let's just go ahead and do that right now. It's a very simple process, but you're going to have to do this for pretty much any actor you implement, except for the UI controls that are inherited down. They'll take care of this for you. But any actor you're implementing yourself, you will have to set the bounds. It's very simple to do. All you're doing is setting, as you can see from the pop-up here, the position, width, and height of your actor. And we're going to get that from our sprite. So we'll just go sprite dot, spell it right, sprite.getX, sprite.getY, sprite.getWidth, and sprite.getHeight, like so. So now this actor knows how big it is when it's drawing, when it's doing hit testing, etc. It is good to go. Next, we're going to tell the actor that you can touch it. That is a matter of calling set touchable.enabled. Now, finally, we're going to go ahead and add a listener to it. A listener, as we've used it so far, we're doing it just for the input events, like the keyboard handler we wired up earlier. However, it could also be used for firing events of your own making, for communicating between actors in the tree, for communicating to children across nodes of actors, etc. In this case, we're actually going to just use the event as the input event, but the event could be anything you created. So you can actually use listeners as a way to communicate between objects. We might cover that in a later video. For right now, again, we're just going to go with strict UI control, strict input-output control as we've seen in the past. So we're going to go ahead and do an add listener, and we're going to do this inline anonymous style. So new input listener, and squiggle, enter. Why did you not auto implement? 1 second. My IDE should have done a lot of work for me here that it didn't do. I think it's because I'm in presentation mode. 1 second here. Oh hell, you know what? I don't have to be that lazy. I'll just type this out. There, and close. those. Let's get rid of the spacing. By the way, if you're from IntelliJ, your presentation mode has a few issues. All right. So that is, I believe, the right number of... Yeah, so we add a listener in. So we're going to have to implement this class inline. And all we're going to be doing is overriding a couple of methods. See if it's smart enough to do here. Okay, good. We're going to override key down, like so. And we're going to show you the very first action that you've seen. Very simple. We're going to see if key code equal keys dot right. So if the user presses the right arrow key, and now I'm about to introduce you to your very first action. I think I just said that. When this is done, we're going to actually jump forward and do another project just about action. So don't worry too much about actions. I'm going to gloss over it a little bit here, but we're going to use as a move by action, like that. Give it the nice name of MBA, like so. And for that action, we set the amount we want to move it by, and we are going to move by 100 pixels to the right and 0 pixels up or down. And you set the duration of that action. We'll make it 5 seconds, like so. All right, we return true to say that we handled this key event. That should be it for my input listener. All right, so there is defining your actions. However, we need to run the action. In order to run it, we have to trigger it off my action. It has a method called add action. So let's just go ahead. We'll trigger that. Since we're in an anonymous class inside, we have to call it like this. And call add action. Call our newly created action. And done. Now, there's one last catch here. Here, I'll go ahead and run it, and you'll see that it does nothing, which is not going to be extremely exciting. And then I'll explain why later. Okay. I need to implement draw. Sorry, that's one very critical thing I should have done. So, that's a constructor for our class. I did not implement draw or act. So, let's get draw. And let's do act, even though we're just going to call the base class as act. So, draw, by default, just calls back to its base. It's being passed in 2 values to deal with. The first one is the sprite batch to draw, or the batch, but technically it's always going to be a sprite batch to draw to. The other thing is the transparency level of its parent. Theoretically, if your parent is transparent and you want to inherit that, you should calculate and multiply your own transparency by that. We'll kind of touch on that a little bit in actions, but for now, let's just skip on from that. So all we want to do when we draw is just draw our sprite to the batch, like so. So like I said earlier, the stage will call the draw method of every single actor. It's the actor's responsibility to draw itself. And let's now see what happens. There you go. So there's our default thing. Pressing the arrow keys, it does absolutely nothing as of yet. Well, now let's go ahead and change that. What I said earlier is our actor has position data, and we used a sprite, but we need to link those two together so that when our position changes, we can update the position of our corresponding or our own sprite. And we'll just do that in this method, called, conveniently enough, position changed. And this will be fired whenever the position of the actor changes. And in that, we just want to set the sprite's position. And we set it to our actor's X and Y, like so. And let's just call our supers version, just in case there's anything down the chain that we're not knowing about. So now let's go ahead and run this. And when I hit the right arrow, we should move by 100 pixels over a duration of 5 seconds. So the action itself is doing the calculation for you. So instead of using the logic of if right arrow down, keep going to the right until this happens, you use an action as a one-off. So in this case, we used move by action, and we moved by 100 pixels. Now let's take a look a little bit closer detail about actions themselves. In order to do that, we're going to start a bit of a brand new project. Actors, action. Open this up. All right, in the sake of time savings, I'm actually using almost the exact same code for our main. Let me just show you quickly what we're doing here. All right, so here's our main class. Pretty much the exact same logic. The only thing that we're doing slightly different here is instead of using actor, we're going to use a class called image. It's pretty much exactly the same, except for it has an internal graphical representation. To be honest, I'm showing you this more so that you can see there are more than one kind of actor, because it's not a very efficient way of doing it. What we're about to do is actually going to create a lot of annoying, ugly code for ourselves. But at least this way you understand that actors can, there are a hierarchy of actors, and you can inherit from these children actors as well. But one of the things that we're actually going to need is to pass it the file to use, the image file to use for its own graphic. So that's the one change here. So instead of just having a blank constructor, we're going to take a texture as our parameter in our constructor. Next thing here, and I'm just showing you this so that you understand that it's available, not because you have to do it this way. But in the previous one, I locally said my actor equals new. So we had a local reference to actor. Here you can see I'm actually just creating the actor right in the add actor call. So I don't have a reference to it. As you can see here, I just want to show you this one quickly. So we're going to do the same thing. We're going to wire up the keyboard handling. But instead, since we do not have a reference to our actor, I did not make a local copy of it. You can access your actors as part of the stage by calling actors.getActors. And then I can use this data collection. Obviously, I can exploit the fact that there's only one value in it, so I can safely call it first. But one really important concept to understand here is stage is ultimately a container. It's a container of actors or classes derived from actor. So if you need to access them or you need to iterate through it, you can call it by getActors. Otherwise, this is exactly the same as if we kept a local reference and did this as 2 lines of code. I just wanted you to see how you can access actors from the stage. Okay, so next thing, let's flip into our actors. Okay, so here you go. Here's our basic class. And instead of inheriting from actor, like I said, we're going to inherit from image, which ultimately inherits from actor. Image is just an actor with a graphical class attached to it. Like I said, this is actually going to make things a bit of a pain in the ass, but it does show you that there is a hierarchy of actors already available for you. Most importantly, and we will cover them later down the road, there are actors called groups, which can be used to group other actors together. Very important. But there are also a number of UI widgets, which again, we'll be covering down the road. But when you're doing a UI of some form, you will probably end up using these controls, which are ultimately, as I said, derived from actor. But let's go ahead and create this guy. So first thing I need to do is create that constructor that takes a texture. Like so. Oh, I need to resolve which. Like so. Okay. Now, our logic is pretty much going to be the same. Let's pass this up to the parent just in case. Now, we need to set our bounds. Same logic. Set bounds, and we're going to set them to our x, our y, our width, our height. That is a very critical call. Always remember to do it. And finally, we are going to add our listener. And that is a new input listener, like so. Once again, unfortunately, it's making me do all the typing. Okay, and we're going to handle keys down. This is going to be a bit ugly, but I'm going to be showing you a number of different actions. So this is all logic we've seen. I won't bother explaining, but I'm going to do just a switch statement based off of the keys that's pressed. So let's switch on the key code, like so. This just allows me to show you a bunch of actions using somewhat condensed amount of code. So the very first one, we're just going to use the number keys across the top. So input.keys.number number 1, like so. And always remember your break, so I always start with them. First thing we're going to show is a move to action, just to make sure everything's working right. We've already seen this before, that this is an action that moves to a certain destination over time. Oop. Ooh. Why did you complete with that? Alright, let's try that again. Move that. Makes a lot more sense. And once again, you just set the position. Move to action.set position, and we will move to, I don't know, 200 and 200. Like so. And duration, stick with 5 seconds. If you want 0.5 seconds, by the way, it's decimal like so. But that's a 5-second duration, and let's go ahead and trigger it. So add action, like so. All right. Now, the one nice thing about using the image as our base class as opposed to owning your own texture or sprite is we don't have to implement draw, which is cool. So I should be able to just go ahead and run this code and find out how many errors I made. 1. Oh, key down handler needs a return. We handled the key. Yes, we did. Alright, let's try that again. Okay, so now if I press the 1 key, the action is applied, and we move over a 5-second duration to the position 200, 200, of course, relative to the bottom left corner. So that's a very simple action. That is a move to. Now, at the same time, you can do a move by. This is where you're moving relative to your current position. Let's use number 2 to illustrate this one. That'd be a move by action. Like so. Same logic. But in this case, instead of moving to a set location, this one moved to the location 200, 200 on the screen. This one will move, here, let's do this one. 200 to the left and none down. Oops. I suppose I should actually call the right method. Set amount. Duration of... Oops, move by action dot set duration. Let's go with 3 seconds because 5's a little long to wait for. Finally, we just run it. Like so. And let's not forget our break. Alright, so this one will now move by 200 to the left. Now, not thinking ahead very much, I first need to apply the first action so that I have space to move. So there's the first action moving us there. And it's done. Now I'm going to press 2, and you'll see it moves by. There are a number of values. This is just 2 of them. There are several more. We'll see a few more of the movement-based stuff. But you'll find most of the movement, scaling, rotating, and translating, have a 2 and a by value. 2 is to move to a set coordinate. By is to move relative to your current position by that amount. So those are the 2 different sets. You'll see, again, they're used... there's 2 and by versions of almost every single movement over time or change over time action that's available in Scene2D. Alright, so now let's do something a little bit different. This one we're actually going to change the color over time. And that is input.keys.number 3 time. Let's not forget our break. Alright. And that is a color action. And this sets a color value over a period of time. First thing you need to do is set the color you want to change to. Color action dot set color. Set end color. That's the color you ultimately want to change this to. Let's go with the color purple. And color action duration, set duration. We'll make that 5 seconds. I bet you can guess this one. You apply it to your actor. And color action. Now, I will tell you right away, this code actually does not work at all. So now we need to do a little bit of work here. Now, I told you the base class was doing the drawing for us, and inheriting from image was going to cause a bit of a pain in the ass later on. Well, welcome to a little bit of the pain in the ass later on. What we need to do now is actually change the drawing a bit. Lost my mouse cursor. So, even though it initially saved us from having to do it, and the image nicely took care of that, now, sadly, we need to actually override draw. So, just come on up here and override. Once again, that's Control-O if you're using IntelliJ, and get your draw method. Now, what we need to first do is tint the sprite batch that we're drawing with. This is what that set color is actually going to do. And we just set that color to the color of our actor. So the actor's color is being changed by the action over time, and we need to actually wire that back to our sprite batch that's going to be responsible for the drawing. Next up, we're actually going to do something for a little bit down the road. I'm going to be showing you, so far we've just done moving, but in order to support scaling and rotation, unfortunately you have to implement your own draw. We saw that much earlier back when dealing with sprites in the first place. You have to implement a draw that has a lot more parameters to it. Well, in this case, we don't really have a texture available. What we have is a drawable, and ultimately an image implements something called a texture region drawable. So now we have to do a bit of an ugly hack. Not a hack, but a cast. And that is, we are going to need to cast back to texture region drawable, like so. And that is by calling our actors get drawable. Get drawable is implemented by image, and it returns basically a canvas that you could use to, it's the least common denominator for drawable images. We know we implement from this one, so we're going to cast it all the way back. This is just a matter of using the image class. Like I said, if you were really going to be doing this yourself, you would probably just use the actor class and implement a texture or a sprite yourself. But since we didn't, we need to get a drawable and turn it back into a texture regionable drawable, because it has the method we need, which is draw. And they all have a .draw, except for the other ones don't have the positional information for rotation and scaling that we need. So let's go ahead and implement that. First, pass in our batch, then our X and Y, and this keeps going for a while, our origin X and our origin Y, and our scale X, and our, you guessed it, scale Y, and finally our rotation. Alright, so down the road, this will enable us to support, I don't know why you're so angry. Okay, what am I missing? Batch X, Y, batch X, Y, origin X, origin Y, scale X, scale Y, rotation. Oh, my bad. Yeah, sorry, there's even more work. Get width, get height. There we go. So this tells draw a whole lot more information it needs. So all this information was part of actor. Actor, as its actions, can change its rotation, can change its position, can change its scale, etc. But that information needs to be passed on, because again, an actor doesn't render, and an image by default doesn't render rotated or scaled or such. So you have to pass this information in specifically yourself. So thus this pass through. So when the draw is called, as draw is called on every entity, we're going to override implement it this way. So now that passes through, and when we deal with position a little bit later on, it will now work. So we jumped ahead a little bit to implement this one, but this call we definitely had to implement so that we could get our color change, which I'm going to illustrate right now. So this is the color action in action. Okay, I did something not right. 1 second. Oops. Alright, that was me being stupid. Let me just go ahead here and stop that. what I did here is I mixed my coordinates up, so I should actually be passing in the origin. So basically I was passing the origin in as my width and height. Alright, why did you not paste right? Alright. Sorry. So this was my mistake. Should have been in this order, like this. I had... Alright, what am I doing wrong here? One too many commas. Actually, two too many commas. Alright, so this should do it. There. Sorry about that. Passed things in the wrong order. Alright, so now if we hit 3, over time, we are going to tint to purple. Alright, so there are a number of actions in there that can control a number of things. You can tween a value over time. Tween meaning between, so it starts with one value and ends at another. There are methods in there for int and float changes over time. You can move things to and by, you can scale things to and by, etc. As you saw, we could even change the color of something over time. Now, what you often want to do is queue a number of actions up at once, either actions that happen in parallel or in sequence. So let's go ahead and show you a parallel action. So if we're going to do this on the, press the 4 key. And in order to do this, I'm going to need 3 actions to run, say. So we'll do a move to, like so. And I don't know, we'll set that to width minus gdx.get graphics.get width minus 200 and height minus 200. So, oop, missed, like so. Alright, so we'll position it there, and for each one of these we'll take, say, 3 seconds. Like so. Alright, so that's one action. I believe it's actually set right. Next we'll scale. That's an SBA equals new scale by action. We will scale both in the X and Y direction, so we'll double up our size, like so. If you do 0.5, it'll halve your size. 0.25, it'll quarter, etc. So that's the scale by action set. Oh, I'm making my own stuff up here. Action dot. All right. Me and IntelliJ are fighting a bit today. Oh, SBA dot. Okay, my bad. Set amount. Double it up. Set the duration. And we'll go with 3 seconds. Alright, so we've got to move, we've got to scale, and let's throw a rotate in. Rotate to. Jesus. Sorry. A little sloppy today. Rotate to, say, 90 degrees. And over again a duration of 3 seconds. Alright. So we got 3 different actions there, MTA, SBA, and RTA, which are going to move by, rotate by, and scale by accordingly. Now, what we want to do is run them all together, and that means we're going to create one more action called a parallel action, like so. And parallel action, you can pass in a sequence of actions. If you have more, you can call it after the fact, but I'll just do it right in the constructor here. So all we do is we pass in our MTA, our SBA, and our RTA. So we're setting our 3 actions to go in and run in parallel. Now you do not set a duration because it's going to get the duration from its child, or its children, I guess would be the technical word. So the action you then do is the parallel action, which groups all those other actions together. So they will run, obviously enough, in parallel. So let's not forget our break, and go ahead and run this. So now if I press 4, as you can see, all 3 actions run at once. On the other hand, sometimes you don't want to do that. You do not want to do things in parallel. Instead, you actually want to do them in sequence. So now through the power of cut and paste, because I'm guessing you can guess exactly what this code is going to look like, let's show a sequence of actions. So obviously we want a different key. Let's show the magic of iteration. So we're going to do the exact same thing, but we're going to do them one after the other. Or I could just use brackets and had everything in its own scope, but cut and paste is easy enough. All right, so now we go ahead. This is, instead of a parallel action, we'll make a sequence action. I guess I should call it an essay then instead. So there's our sequence of action. Oh, I guess I should actually make it a sequence of actions, like so. And if you run that, you will now see the move will happen. Oh, yes, you press the key. You'll see the move will happen. And the scale will happen. And then the rotate will happen. So as you see, you can sequence actions together. You can either use them in parallel, which by the way is the default. So if I just did all the add actions without using the parallel action, you would have had the equivalent of a parallel anyways. Or you can sequence. So one happens, then the next, then the next, then the next. There's another really neat thing that comes in, especially if you've got sequences. You want to put a little bit of logic in there or something that isn't actually an action, is you can use something called a runnable, which is basically just in the sequence, when I call this action, I want you to run this code. Now let me go ahead and show you one of. I guess it makes sense. What we'll do is we'll use the runnable to reset everything back to normal. So now we need to handle 6 keys.num underscore 6. Okay, and a runnable action raw like so, and it takes predictably enough a runnable. A runnable is just a piece of code that's going to run that implements a single method called run. Easy enough. So let's go ahead and make a new runnable. New runnable, set runnable, new runnable, like so. Boom. All right, so now we need to override the run method, like so. And then in our code, we will just go and reset the position, my actor.this.set rotation, and my actor.this.set scale. All right, so when you click, when you hit the number 6, the next action is going to be a runnable action, and the runnable is just going to do this chunk of code. Now, once again, where this is quite powerful is this runnable action could have been sequenced in here or here. So you can add some logic beyond the actions that are implemented. Or, of course, you can implement your own actions as well, just inherit it down and go from there. But let's see this guy in action. All right, so first thing, let's do something with it. Okay, all done. And now let's hit, I believe it was 6. No, it might have been 5, 6. Nope. Too many. All right, first off, I forgot my break. Oh, I forgot to run the action. Duh. All right, let's go ahead and run the action. That might help. Okay. So, go ahead and run that, and once again, we'll let it do something. Alright, and now if I hit 6, boom, that action runs right back to normal. So, those are how you you can handle actions and apply them to actors within Scene2D. Now, the nice thing is, if you're coming from a world of jQuery or something like that, this might start looking really longhand. You remember something called chaining, and chaining is a way to make code much shorter. Pretty much you're passing a return type into a value, into a, like, you take a function, passes return type into another function. Well, LibGDX has implemented default versions of a number of these actions as static classes. Now, the neat thing is you can do an import and bring them in. So up here, we're going to go import static bad logic GDX scenes scene2D actions capital A actions star for everything. All right, so that's going to import that static class, which is going to have a lot of nice little convenience methods in for us. So let's go ahead and we're going to implement our parallel version, this, except for we're going to do it in a lot less code. So again, if you're used to jQuery, this is very similar to what chaining looks like in jQuery. So keys dot, let's do space. And instead of creating a new instance of everything, we're going to use one that's already done. So we're just going to create called parallel, and we're going to pass into parallel our actions. So first one is move to, and we want to do, I don't know, 200 over 3 seconds. And next up, we're going to do a scale to, and that will be double over a period of 3 seconds. And finally, rotate to and 90 degrees over 3 seconds. All right, and should be the extent of it. So, and my always forgotten break. All right, so you'll see there's a lot of shorthand here. We don't have to. One sec, I got a cough. Sorry about that. I'm starting to get a bit of a cold and I'm losing my throat. So anyways, what we need to do here is we, instead of creating a parallel object, we're using one that already exists, and we're calling static versions of each of the classes. It creates a much shorter version. You're not having to create the new version, set all the parameters, etc. It's nice, inline, compact, but this is essentially the same code, much shorter as this, except for it will also automatically do that part for us. So now I should just be able to run this. And nothing happens. Okay, I made a mistake again. Which is my day. Okay, I did make a big mistake. We still need to add it. But we just pass in our parallel, like so. Done. Sorry, that was my mistake. So now we go ahead and run that. Ta-da! All at once. So that's the basics of it. You have your stage, which is your base container for all the things in the world. You have your actors. As we saw in this demonstration, there are child actors available, or child classes available to inherit from, such as image, which is just an actor with a visual representation. Otherwise, your actor class is just pretty much a data type for being stored in the stage container. It's got a position, it's got scale, it's got all those things, but it doesn't have a graphic, so you need to hook that relationship up. So the very important thing to remember is the call to set bounds. Finally, you have your actions, which control how your actor goes. As you saw, there are a lot of actions that they inherit from temporal, which means over time. Time-based actions, such as your move, your scale, your color changes, etc. There are probably 20 more actions I didn't cover today. On top of that, you have your sequencing actions, so you can do things like run things in parallel or in sequence. Also, you have the runnable action, which allows you to run code as an action. Then finally, you can use that static import and create this much shorter version of it. So that's the basics of using actors and actions in LibGDX. Strung together, they seem very simple at first, but strung together, you can create some very complicated programs, but have the code maintained in a very logical manner. So in this way, as you saw, we use the actor to handle its own input. So you can keep things logically consistent if you want, or you could have the stage handle all the input, and the actor just does what it does. On the top of that, we saw handling inputs for handling events for handling input. At the same time, events could be used for things like telling an actor to die, or that it died, or so you can communicate between things with events. The key thing again is your stage calls .act to update the acting and .draw to update the drawing of all of the child actors within the scene. And then actors themselves can use actions to do stuff. So that's the basics of it. There's more to Scene2D, but that's the crux of what you need to get a game going. Next we'll probably either look at grouping or UI. I haven't decided which yet, but hopefully that was helpful. Hopefully I still have a voice next we talk. Thank you very much. Bye.